group31 video submission. This is our project proposal for the smart neuropathy device. The proposed project is an enhanced neuropathy treatment device using proprietary ASIC from a Certec Medical. Our inventor is going to be Rex Hales, and our team consists of Alex Chang, Charles Kangas, Christian Merton, Cody Robbins, and myself, Thomas White. We have varied experience across several domains that will help make us successful for this project. The problem are peripheral neuropathy. It comes in two primary forms, delaminating and axonal degeneration. So the neuropathy is a myelin, is a thin layer that surrounds the nerve, much like insulation around a wire. Reduction in this myelin results in a slower nerve conduction speed. And then the axonal degeneration is just long arm-like structures at the end of the nerves that transmits an electrical signal, and the amplitude of those signals are reduced. So those are some of the challenges.
One of the primary tools used to diagnose neuropathy is by using an NCS, or nerve conduction study. This is done by placing electrodes at the end of a nerve group and then using a probe to send a signal from the base of the nerve group to the electrodes at the end of the nerve group. The transmission characteristics, if they are degraded, indicates that you may have neuropathy. There are also various devices on the market designed to treat neuropathy symptoms, specifically TENS units. A TENS unit works by placing electrodes across an affected area and applying a broad electrical stimulation. But there is nothing smart or targeted about the way these devices treat the area. They do not target specific nerve groups, they simply blanket the entire area in a broad frequency blast.
I wish to discuss our proposed solution, a smart steam device. Using a Certec CS1080 NeuroSense and CS140 NeuroSteam module, we can combine these two technology into a smart treatment device. The device will first use the NeuroSteam module to send the steam pulse through the target area, and the NeuroSense module will measure the result and compare against the health baseline. Different types of nerves within the same group will exhibit slightly different timing and amplitude in the induced response. By analyzing data, we can determine in which nerve type shows the most degradation. Then, the device will use the steam module to treat the area by emitting stimulations with the pulse characteristic that target within nerve group. Analysis determining the most damaged.
So in terms of project implementation, the CSI-80 currently interfaces with the evaluation board, and we're going to have to develop a new board that slots between the CSI-80 and the evaluation board. This new board will require a pass-through for the SPI interface, as well as a new slot for interfacing the CSI-40. We're also going to have to do the ARM microcontroller programming. So we're going to have to program it to act as a controller and a signal processor, and this will also control hardware timing and data output for both the sense and the stim. And then we're also going to develop an additional Android application using the microcontroller, and this is going to scan the results, and current treatment data will be displayed to the users on the app.
The most difficult aspect of our project will be reliably capturing the necessary data without destroying the sense module. The stim induces volts of 15 to 18 transients, while the sense can only take 10 millivolts. To protect it, we determine two ways: blanking, where we use a hardware to turn off the sense chip while the stim is active, and a diode bridge to step down the voltage before it enters the sense module. Both these methods can end up skewing the end result neural data. Our proposed project will combine both the neural sense and neural stim modules into a smart neuropathy device. This device will perform a scan using existing techniques and in order to identify damaged nerve groups. Our key challenges are going to be designing a custom board with SPI pass-through, ARM microcontroller programming to process the signals, and protecting the sensitive sense modules from the high voltage stims.